Hail Nye the science guy.
Hail, 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 hail.
The sun.
The sun, the source of all energy. We are making this video to show you how all energy goes from sun to run. Wow, sure is raining outside. This rain provides a perfect example of the water cycle, which gives off water needed for photosynthesis. The water cycle. We start with a body of water, which then evaporates into the air, condensing in the clouds, which then precipitates down, and the roots of the tree sucks up the water, which is used for photosynthesis.
Go ahead.
Photosynthesis. Photosynthesis starts in the chloroplast within plants. It is a light-dependent reaction on the surface of the thylakoid disc. Light energy enters our photosystem number 2, which takes in water and gives off 2 H+ ions and oxygen, and releases an electron that produces ATP for the light-independent reaction, which then goes to photosystem 1, which gives in more light energy and produces another electron, which enters the electron transport chain, changing NADP+ to NADPPH. Our Calvin-Benson cycle. We take 6 carbon dioxide ions, which we get from the air, and we enter stage 1, where we get 6 C6 ions from our 5 carbon molecule gained from earlier. We go to 12 3-carbon molecules and use we break down ATP and ADTPH to produce 12 pGal, and 2 pGal leave to make glucose until 10 pGal come in, and we add ATP to produce another 5 carbon ion to restart the Calvin-Benson cycle. This continues to make more and more glucose, which is energy for the plants. That's it.
It all starts out at the bottom of the trophic levels with our producers who undergo photosynthesis.
Now the energy makes its way up the food chain /web.
This is a food chain showing our different trophic levels.
And we start at the bottom of the trophic levels with producers. Our producers are then eaten, going to our primary consumers, secondary consumers, and so on. So this shows our main food chains. This is just one example. And this, as the energy goes further down, we get less and less energy.
Okay, this is the food pyramid. The producers start out by doing photosynthesis, which the consumers eat these producers. Then the secondary consumers eat these consumers, and then we eat everything else.
This is through energy transport. So from the primary consumers eating the producers, glucose is transferred. Same thing from the secondary to the primary, glucose is transferred. And same with us while we're eating all the other things. Glucose is transferred, and that's how we're getting our energy. As humans, we are at the top of our food chain as tertiary consumers. We get our energy from the glucose produced by plants that have made their way up the food chain.
Food starts off in the esophagus, where the salivary glands secrete starch-digesting enzymes. Then it goes through the esophagus into the stomach, where it adds acids, enzymes, and fluids to grind food to a liquid mass. Then it goes into the small intestine, where it secretes enzymes that digest macromolecules. And then it goes into the large intestine, where it absorbs water and salt. Passes remaining undigested material and some water out of the body. Now that digestion is done, the mitochondria can now begin cellular respiration.
Cellular respiration is a very important part of our body. It's how we get all our energy. Now we start out with our glucose molecules, which we get from eating multiple things, which they start out at the bottom of the food chain and come up because of plants. Now we start out with our glucose molecules, and we have to go through glycolysis, which breaks down into 2 3-carbon molecules called pyruvate. These pyruvate either go to an anaerobic process called fermentation, or aerobic process called the Krebs prep, and then more on to the Krebs cycle. Now if we don't have any oxygen, we go to the fermentation. Now this creates very little amounts of energy, but doesn't require oxygen. You get a lot of lactate buildup when you go through fermentation. But after your fermentation, if you have oxygen and you stop exercising, you can break down the lactic acid and go back to the aerobic process called Krebs prep. Now, at the beginning you have oxygen, you go straight to the Krebs prep. Now, this breaks down the pyruvate into molecules so we can go through the Krebs cycle. The Krebs cycle is one of the most important things that happens in the mitochondria. This gives us tons and tons of energy, and it's going on constantly. Krebs prep cycle is our main way of breaking down the glucose to get all of our energy. This is a more detailed diagram of the Krebs cycle. So we start out with our acetyl-CoA, which we got from the Krebs prep cycle. And this goes in the cycle and splits down into a five carbon molecule, giving off CO2. Now it continues around the cycle to break down even further, producing more compounds that will eventually end up to ATP. We break down to a 5-carbon molecule, giving us another CO2. This breaks down even further to a 4-carbon, producing more CO2 and giving us more energy, and eventually to a 4-carbon molecule, which then joins the acetyl-CoA to create a 6-carbon molecule. Now we get a net gain of 36 ATP. That's where we get most of our energy.
Now that cellular respiration is done, we now have the energy needed to have muscle contractions.
The myosin head is attached to the actin. The myosin head flexes, advancing the actin filament. The myosin head releases and unflexes, powered by ATP. Myosin reattaches to actin farther along the fiber. The heads on the two ends of the myosin filament are oriented in opposite directions. When the heads attach to the actin, they bend toward the center of the myosin. As one end of the myosin filament draws, the actin filament end is attached Z-line towards the center. The other end of the myosin filament does the same. Both Z-lines move towards the center and contraction occurs. The muscle is at rest. A long filament composed of the protein molecular tropomyosin blocks the myosin binding sites of the actin molecule. Without actin's ability to bind with myosin at these sites, muscle contraction cannot occur. Calcium ions have bonded to another protein molecule, troponin, which is a part of the actin myofilament. The resulting complex repositions the tropomyosin, exposing the myosin binding sites of actin. The myosin heads can bind to the actin and contraction occurs.
Our respiratory system is the process of breathing in and out, allowing our blood to get our oxygen and our carbon dioxide out. So in the lungs, we inhale our O2 and exhale our CO2. But it happens on a smaller scale in the alveoli. There's many capillaries in the alveoli that diffuse out the CO2, which is not abundant in the air around them, and bring in the O2, which is not abundant in the blood. This allows us to get rid of the harmful CO2 gas in our bloodstream and allows us to take in the oxygen we need for our aerobic cellular respiration. For oxygen and glucose to reach the mitochondria, which is needed for cellular respiration, we need our cardiovascular system. Go.
Man, my heart's pumping hard. This brings O2 and glucose to the mitochondria for cellular respiration. This gives us energy.
After all our processes are done, we need to use the excretory system to get rid of all unwanted waste.
Our excretory system is a very important part of our body. This gets rid of the unwanted waste that we don't want, allowing us to maintain homeostasis. So a part of the excretory system is our urinary tract, which begins with the kidneys. The kidneys' main purpose is to filter our blood, which is very important. And what's filtered out goes down through the ureters into our bladder, which is then urinated out. Another part of our excretory system is our skin. We sweat out many unwanted substances through our skin, and as well as part of our digestion tract, with our large intestine, we expel the more solid waste that we can't go through any other way.
The trophy follows with a process called photosynthesis.
Are you ready? You just read it!
It all starts out at the bottom. What? Okay. It all starts out at the bottom of the trophic levels with our producers who undergo a process called processing. Okay. It all starts with the process. What? It all starts out at the bottom. Okay. Come on, dude. I just keep forgetting. I memorize it.
You can't hide behind the ledge.
I'm not hiding. I'm leaning on it.
Ready? 3, 2, 1, go.
Got it all.
You ready?
All one.
It was a change up, bro.
That's a strike.
Oh no! That's a bomb and a half. No.
Ready?
Yeah.
Wow, my heart's pumping hard. This brings. Oh shit.
Okay.
Oh shit. There's the grass. Okay. Okay. Okay.
3.
Okay.
All right, ready? 3, 2.
Wait, do I have to start all over?
Yes.
Come on. Okay. Go.
3, 2, 1, go.
Okay.
Oh my god. No, I can stand up here.
How would I get it off? It has a lock.
We have to like. Sun is raining outside. It's a great example of how water goes. No, not that one.
It's the first one.
Wait, I have to finish. Yo, the
It's
sun
the
was
very
doing its
first
job.
one.
Sun is a source. Sun's. Yo, sun's still screwed. Sun's also gonna get the nipples twisted. Sun's don't have nipples. Joke's on you.